choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Welcome back to this co-video edition of the Wonderful Space Junk podcast. I am joined today live in the studio of a social distance away by fabulous Rami Mando. Rami, how are you?
I'm great, Annie. How are you?
I'm doing really well. I've got a good stockpile of a sensible amount of toilet paper. I've got my glass of Chardonnay. Life's actually not too bad inside.
That's great to hear, and I've got my glass of Chardonnay here with you as well.
So, Rami, I imagine the international viewers of this, I keep saying listeners, I'm getting better at saying viewers, will not necessarily be that aware of the Space Australia website or of the wonderful work that you are doing. So, would you like to explain for anyone who isn't aware who you are, what it is you do, and anything else you think is interesting?
Yeah, sure. Okay, so I have a couple of hats that I wear. The first one is I am the founding director of a community space platform called Space Australia. Now, Space Australia is a bit of a media platform at the moment, but more of a outreach, educational, citizen platform and community platform for people across Australia and New Zealand to get involved in space. So what we want to do is we want to share the stories from the Australian space community, and we want to tell people about everything that is going on in the Australian space community, since we are growing as a nation when it comes to space. On top of this, I actually also am studying my master's with Swinburne University. Sorry, my master's in astrophysics with Swinburne University, and my focus is actually looking at a type of star called a pulsar, and it's a really compact star. It spins really fast. It has a whole lot of gravity in it, and in that gravity, it actually it sends out signals to Earth. And we measure those signals using telescopes like the Parkes Radio Telescope. So there's a couple of things I do there. There's there's the Space Australia stuff, and then there's my science work as well.
That's brilliant. Okay, so pulsars, you were saying, and you can measure it using the Parkes telescope. What sort of what are you measuring? Are you measuring light? Are you measuring radio frequencies? How are you detecting it?
Yeah, so it's what we call light, but it's actually radio waves. So, the electromagnetic spectrum itself is made up of different components. One component is a very thin component, is called visible light. It's what we see with our eyes every day. It's what we interact with. But there's also different components that are like, infrared part of the spectrum, the UV part of the spectrum. Down the very lower end are radio waves, and radio waves come through on your radio, your FM radio, for example. Now, what we measure is the radio waves or the radio light coming from a pulsar as its beams sweep past the Earth. So, if you can imagine a pulsar as a small sphere about 20 kilometers across, and it's actually spinning really, really fast. Some of these spin at about 700 times a second. And from the north and south pole of this pulsar are these beams of energy that sort of radiate outwards at really strong beams of energy. A bit like a lighthouse. Now, every time that lighthouse spins past the Earth, it pulses past us, and that's what we see. That's what our telescopes see. We see the pulses of light from these pulsars, and we can measure things with that information. We can learn about how fast it's spinning. We can learn about what's between us and the pulsar. We can learn about if it's got a companion as they orbit around a common center of gravity. We can learn, there's a whole bunch of things we can learn when it comes to pulsars science. So they're kind of really cool objects. What makes them super cool is they've got this intense gravity. They're about 1.4 times the mass of the sun squeezed into a space no bigger than a city. And if you stood on one, you'd be completely flattened and killed within microseconds. But it's such an intense gravity that it actually it can drag the actual space-time around it as it spins, and cause relatively stick delays in what we see when it comes to the science we record.
What got you interested in pulsars and more broadly in space? Have you always been interested in space? Were you one of those kids who had a telescope in the backyard?
Yeah, so I actually never actually had a telescope in the backyard, but I have always loved space. Since as far as I can remember, 6 years old was probably the earliest memory I have of space. And I kind of have, it started off in well, let me go back a second. I was one of those little shit kids that actually said why a lot and asked questions why. And so I remember like when I was watching TV with my mum, and it was quite a very clear memory to me. It was around Australia Day, or just after Australia Day, in 1986, and I was 6 years old at the time. And I remember my mum being really upset at some news that we were getting. I think it was actually the day after, the news that we were getting out of America. And it was because the Challenger space shuttle had exploded. My mum was really upset, and I really didn't know why she was upset. And I questioned why, and she had said, people had passed away. And that, I think, was my first experience with death. And I think that kind of went, whoa, why? Why does this happen? And that actually, triggered off more of my questions. Now, from that, I figure out people are going to space. Why were they going to space? What's in space? What is space? And as a kid, you kind of go, whoa. And then a few months later, in the same year, to really amplify what happened to my brain at the time, in 1986, we had Halley's Comet come past. And I remember as well, I was in year one at the time. I remember my teacher, Mrs. Hamilton, and she made us make these paper comets with cellophane tails as kites, so that we'd fly them as kites in the wind, and so we'd actually have comets in the air. And I was too young to actually see the comet back then, because I didn't really know what was going on when it came to telescopes and things like that. But those two things really sort of triggered and pretty much changed the course of my life forever. I just went, yeah, I'm in. I am 100% in, and I'm here for it. So that's how I love space, and that's how I got into space. And ever since then, I've just been doing lots of reading, lots of studying, getting involved and going into space things. I formally didn't start my space education until 2018, where I've actually entered into my master's. But because previously I come from a business background, but effectively.
Oh, really?
Yeah. So I actually, I've actually studied business, got my commerce degree, and worked in finance for 12 years. And so I'm not from a space background, but as a hobby, I've grown up reading space. I read textbooks, and I've qualified enough to actually get into a master's degree without the undergrad physics part of it as well. So I've always loved space since I was yay high.
Right. That is really interesting. So I guess having that that business background and working in finance and so on must have been very helpful for you when you came to think about starting Space Australia and so on. I mean, what led you to start it?
So it's actually been, the Space Australia side of things has had it's got a bit of a story arc in itself, and it comes from that finance background, I guess. So I'll just very quickly pop through how that all came to be. So when I was working in finance, towards the end of my finance career, I was brought in to build a bank here in Australia called Rabo Direct. It's actually an international bank. And just from my, from my finance background. And in the course of building that bank, we learned a lot about digital. This is like 2006, 2005, 2006 we started. So, websites and social media weren't really big back then. But through the course of actually learning about the digital world, I effectively, and building the bank, I effectively got a real big passion for it. And by the end of 2010, I was like, I'm going to do something with digital. At that point in time, I started my own social media agency, which was a company that provided social media services to small businesses in a local area. And this is 2010. So this is well before the wave hit of, let's all get a Facebook page. That already established my next 2 years as a career in the digital world. And that led me to working in numerous things like social media intelligence, into developing a registered charity when it comes to social media services providing online, and working for the New South Wales government for 5 years, running their entire digital team. Now, on this hand, by this point, I had a wealth of knowledge about social media, about digital, about websites, about apps, about newsletters. And on this hand, I had a drive, a passion, a fire about space. And I just thought, why don't we go like this? Why don't we put digital and space together and build something that actually is a digital platform that allows space to be communicated out to the audiences around Australia, and really start telling those stories for the space community and by the space community. And that's how I got to Space Australia.
It's a really interesting thing, the fact that when you dig into the space community, you find a lot of people, especially in Australia, with a background not in science, although they have scientific capability, but in business and finance. Like the Gilmore brothers who started Gilmore Space, they were in banking and decided to start a rocketry company. And I always find it really fascinating to find out the paths that get people to the places that they've ended up.
That's a really, really fantastic point you make there. And I think for me personally, and a lot of people I know, is derived from the fact that, Australia has been involved in space for a very, very long time, as you would know from the, from 50s and 60s when we had our own Woomera launches, etc. But we never actually officially had an agency here until 2018, July 2018. And prior to that, space was very much if you're in the industry, then you're industry, but if you weren't, you weren't. So for people like me, when I was growing up, and this goes back to that, that 10-year-old me at the time, I remember saying to my dad, I want to be an astronaut when I grow up. And my dad's a realist, so this is not any negative criticism of him. But he just said, look, to be honest, it's a tough gig and you probably won't get a job. We don't have astronauts here in Australia. We don't have a NASA here in Australia. There's no space agency. You won't be able to become a US citizen, and therefore it's probably a dream that's not going to be realistic. And I think for us, people my age, and I'm 40, growing up in the 80s, 90s, and even early 2000s, that kind of steered the path we went into, which is most likely an unlikely space path. From about the mid-2000s onwards, I think for the last 10, 15 years, things have been changing a little bit. There's been a bit more momentum. So there's been a few more career paths established. So you are getting people coming through the system now who are, career space, whereas most of us are non-career space, but we come into the career space bringing our skills and our knowledge from other areas as well.
I'm also really interested in your work with social media and more generally with I don't want to use the word general public, but it is the term, I suppose, for everybody to be involved with space, and the fact that even people who don't work in the space industry or the space sector or in space science have an interest in space, particularly kids, but honestly, adults as well. The more I talk to people, the more people reveal how much they love space, and whether it's because they're a big fan of Star Trek or because they like to do amateur astronomy or astrophotography, or they just enjoy looking at visualizations at planetariums and they find that fascinating. It is a real interest. And so that brought me to choosing Article 11 of the Outer Space Treaty for our discussion, which I think is notable in one particular little phrase, which we'll get to, but I'm going to read it. It goes across 2 pages, but it's actually quite short. So, of course, you and I know this well, but for others who have not heard Article 11 of the Space Treaty, here goes. In order to promote international cooperation in the peaceful exploration and use of outer space, states parties to the treaty conducting activities in outer space, including the moon and other celestial bodies, agree to inform the Secretary-General of the United Nations, as well as the public and the international scientific community, to the greatest extent feasible and practicable, of the nature, conduct, locations, and results of such activities. On receiving the said information, the Secretary-General of the United Nations should be prepared to disseminate it immediately and effectively. So the bit that stands out to me in this article of the treaty is, okay, inform the Secretary-General of the UN, fine, but as well as the public and the international scientific community. And those 2 groups are broken out and specifically referred to. And it's in this article of this treaty, but if you've read the rest of the treaties, you'll know that it keeps cropping up, this phrasing. And so I wanted to ask you, what do you think sort of might be some driving factor in choosing that wording, or what is important about the public and the international scientific community knowing about what's happening in space?
Yeah, so I guess it comes down to, from my opinion anyway, in my perspective, look, we all live in this beautiful spaceship called Earth. Now, unfortunately, the spaceship Earth is divided into things like countries, borders, etc., where we have different sort of laws, jurisdictions, and sometimes there's conflict. Space doesn't care about that. Space, there's just no borders. There's nothing like that. So the benefits are actually, or any learnings that come from space, for example, should be shared for everyone because there's different ways you can look at this. For example, if the science community finds an asteroid coming from space, then everyone on Earth should know about it because there's a potential risk to everyone on Earth. You shouldn't have one country knowing about it versus another country. But there's also benefits in terms of some of the innovation that we have building across the planet, and the technology, and distributing that technology and innovation out to people across the world, because effectively it should be for everyone. And I'll give you a good example. It's a really random example, but in I think it was the early 90s, scientists at the CSIRO were looking for, radio astronomers in particular, were looking for if baby black holes existed. Tiny little black holes, and they were testing this infrastructure and engineering and this technology to find these black holes. Now, they didn't find it. And we know that, as far as we know right now, they don't exist. But effectively, what they did find was something that changed the face of the world forever. And nearly every person on the planet will probably use this now because in one form or another, especially in Western developed worlds, what they found was a way to actually transmit over the air between devices. We call that Wi-Fi. And it came from CSIRO scientists here in Sydney looking for baby black holes, and now look at the benefit it has to the world. And that's why I think that wording in particular in Article 11 is about being transparent, about being democratic, and about being open for everyone in terms of both the negative and the positive when it comes to space is so important, because there are risks that come from space. Earth is a beautiful sphere of protection for us, but there are also benefits that we can have through learning about space and also going to space as well. Very quickly, another quick example of that is when the Apollo mission was going on and people went to the moon. The amount of innovation that went into that project to actually counter all the different risks that occur with humans going and leaving this beautiful spaceship Earth have generated so much value to the humans of Earth right now. Every single fireman around the world who wears a fireman suit, or fireperson suit, I should say, sorry, when they actually wear those suits, it's because the material was designed to withstand fires that generated inside the Apollo spacecraft. Dialysis machines, for example, anyone with kidney failure or kidney problems, dialysis machines came from the Apollo program. And without, the reason we went to space was to get to the moon, but the benefit we got out of space was because, is the actual value that we have, all the different innovation that came out of it.
What is citizen science?
That's a very big, that's a big question. I don't want to define it because it's actually something that people can define very differently. I prefer to use the word community science rather than citizen science. Citizen science is a more common word. The reason being, citizen science means that you're a citizen of a place or a location, or you live under a flag. The community science means that you're more open to everyone. But I use both words interchangeably, and my preference is it's just my personal preference. So in terms of community science, it's basically science that the community and anyone in the community can do. Now that could be as simple as a bunch of school kids going up and looking up at the stars every night and noticing the constellations change as they shift, through the months. We have in July we got Scorpio, in summer we've got Orion. That's citizen science, because they're recording that sort of data. Now, it could be something as complex or as deep as people going in and classifying galaxies or dinosaur bones or whatever it may be on platforms like Galaxy Zoo or one of those citizen science platforms. Or it could be something like heading out in your own backyard and getting your neighbours to do this as well, and just counting the number of insects that you have in your backyard of different types of species. And then all coming back together saying we have 25 different species in a 1 block radius from us. That for me is community science, and just getting people involved, in particular the community involved in science. And when I say community, I mean people who are not from a science background, but from the general community.
Right, so the public, as opposed to the international scientific community in the wording of Article 11. I often find it interesting how science, and particularly that sort of community science, is generally aimed at children these days, and it hasn't always been that way. The fabulous Ingrid Okert, who will be on Space Junk podcast very soon, has done a lot of research on the beginnings of science on TV, and it was actually really aimed at everybody, but mostly adults. And I think that if you think about Sputnik, when Sputnik was going through the skies and everyone went outside to look for it, it was everybody going outside to look for it. It wasn't like, all right, now I have a kid, so we'll go out with a telescope. But
Yep.
for some reason, it's almost as though science has become this commodity that can be packaged up in a sparkly box that you buy from the toy store and, handed to a child. And it's like, all right, now you go and do some science and entertain yourself. And I think it's really important to think about how adults and the broader community, not just children, can be involved in science and community science, and also to distance that from the marketing efforts of those sort of junior scientist things that are very much aimed at kids. And it's very much a case of buy the thing so your child will be smarter, rather than do a thing together because that's good for our community. I don't know.
Yeah,
what do you think on that? Am I being too cynical?
No, not at all. No, I 100% agree. And it's no more prevalent to me than it was than when I actually went and had to buy some Christmas presents just last Christmas ago. Now, I don't like buying. I don't like. I'm not a presents kind of person. I'm more of an experience kind of person. So, but there's a lot of kids in our group at the moment, and I'm trying to get them all to learn about science and going out there and seeing even the gender biases inside in the kids' STEM toolkits, for example. I was like, wow, it's really full on. One example was, the girls had make a perfume kit where the guys had explore dinosaur bones and, build a robot. And I was like, well, hang on a second,
Right.
that should be. In terms of I'll answer your question in two parts. First of all, I love that kids do get involved in STEM activities regardless, because if it's like me when I was 6 years old and it gets them to sort of trigger something that goes, yes, I want to learn about space, I want to learn about dinosaurs, I want to learn about, whatever it may be, then fantastic. But I also 100% agree in terms of the adult angle, and in that a lot of adults, and especially from my generation, were not really taught through school curriculums things like critical thinking. We had to learn that after we left school. And I think if we start targeting STEM activities at adults along with children, so children are going to come up through the system, they'll sort of learn about that regardless. But adults who are past that point of learning, but I think getting them to involve in STEM activities starts installing skills like critical thinking and critical analysis, which then actually allows us, the world, to actually become a better place, because people start looking at pieces of information and sort of applying critical analysis to them. And in times like now, as we have coronavirus spreading, and you see a lot of misinformation online, and I've seen it myself. I wish I could have gone back in time. If that'd be my one wish. If I could build a time machine, I would go back in time to when curriculums were first written, and I would actually make sure that critical analysis was actually part of the curriculum for everyone from the 50s, 60s, 70s, 80s, because effectively it would change where we are today. And that's why I think adults are really important in targeting for STEM activities.
Right. The other aspect of it, of course, is about accountability. So if you have to tell your population and the population of the world what it is that you're doing in space, it makes you accountable to their opinion about it, which I think is a really important aspect, particularly in the Cold War context, but possibly even today. It's like things like targets for emissions reduction, for example, they are public and countries announce them publicly. And in that way, it makes governments accountable for their decisions to the people of their nation, but also more broadly through the United Nations and through international organizations across the world. I think that is a really big strength of the way that information is shared in a contemporary setting. But I like that Article 11 sort of builds that in, that idea of, if you think about the Outer Space Treaty as a way that we could avoid going to war or at the very least, avoid nuking each other in or from space. A big factor of that is being accountable for your decisions and actions. Do you think that accountability has increased because of social media? Or do you think in some ways the ability to manipulate people's perception might have counteracted that? Or, I mean, what do you think about that? Because it's kind of a complicated one.
Yeah, totally. It's spot on. It's a very complicated issue. So I think both is my answer. I think we had a peak period in the rise of social media when accountability was really good for social media, but I think that spawned the I don't want to use those two words that who uses, but effectively that spawned the false stories that are spreading
reporting.
So I guess from my perspective, look, accountability is extremely important when it comes to space, because I said there's risk involved in space, but there's also benefit involved in space. In terms of when it comes to social media, there's a strong there's a lot of research that's been done into something called your strong ties and your weak ties. And what those two words are fancy words, but what they basically mean is your trusted network and your non-trusted network. And a trusted network is something like a Facebook platform where you have your family and friends on there, again, who you trust, because effectively, why would they lie to you? Sure. It's your family. But effectively, they pass content on, no matter what that content is, and that content could be not critically analysed before they pass it on. Now, if it comes through your trusted network, you have a very high chance of going, I trust it, I'm going to pass it on. But nowhere along the way has anyone done any due diligence, which is why it makes platforms like Facebook, in my opinion, a little bit more dangerous than platforms like Twitter, because effectively Twitter is, whilst you have your connections on Twitter and your people that you talk to on a regular basis, there are also a bunch of random people that interact with you. And if they send you some information like, we're all going to die tomorrow, or hey, I found aliens, then you're effectively going to go, well, I don't need to trust this. I can block them. I can get rid of them. I can not pass it on. But when it comes from your family, you might actually go, hang on, why would my family lie to me? I should pass this on. So trusted networks versus untrusted networks is a major part of where that misinformation comes from. And effectively, any news, and aliens is a big one when it comes to space, that is misinterpreted or misinformed, spreads faster through trusted networks than it does through untrusted networks. So social media has a big role to play, in my opinion, and I think we need to get better as a community as a whole at how we manage misinformation on those platforms.
Do you believe in aliens?
Look, from a I need to see the evidence perspective, I still need to see the evidence, but in saying so, I also believe in the Drake equation, which is a beautiful equation. It shows, the number of stars which are habitable, which might have intelligent life, etc. It actually would mean that there should be thriving civilizations out there. And the fact that we keep finding, like when the Drake equation was first written, one of the parameters of that equation is the number of planets out there in the universe that have intelligent life on there. And at that time, that number was 1. Now, we still haven't found intelligent life anywhere else in the universe. That is us. And, intelligence is a big question there as well. But effectively, the number of planets in that, which is another parameter in that equation, has risen dramatically. Spacecraft like TESS, for example, and Gaia and Kepler have, I think the number somewhere like 4,500 exoplanets at the moment. So the Drake equation number keeps getting higher and higher. And I think there's, I personally think there are other civilizations out there. I personally think they're also too far for us to actually ever have made contact with them. And given that we orbit a very ordinary star and we're a very small planet, and that our radio, our electromagnetic signals have only been transmitting for, let's say, a maximum of 70, 80, 90 years, they don't know we're here yet. So I think they're out there, but we can't see each other as yet.
Sure. I think we better wrap it up shortly, but final question for you, or discussion point, is if our viewers could go and Google anything, think about anything, read anything, what would you suggest that they do?
Okay, so I'm going to play to my own biases here, so forgive me. But yeah,
Go for it.
but the first one is obviously I think that I mentioned critical analysis earlier on. That's the more serious side of things. I think that's really important. I think we should get that out there as much as we can. So definitely look at critical analysis and some really good articles about that. But for the science part of things and the really exciting part of things, I would 100% recommend pulsars. And
Okay.
I'm not saying it just because it's my field or the field that I love, but because they're just extraordinary, laboratories and objects in the universe. They're extreme objects. They're one step away from the black hole, and that's that pushes our knowledge and our boundaries of understanding. They are able. If you read about pulsars, you get to learn about the life of stars, the death of stars, different types of stars. What happens when a star dies? What happens when a star is born? So by learning about pulsars, you learn about the whole range of astrophysics when it comes to space stuff. I also would recommend. I love my science side as well, but I'm a humanities person as well. I'd also recommend checking out the history of space from a context of humanities understanding. So my nationality is Assyrian, with an A, Assyrian, which is formerly known as Sumerian or Mesopotamian. My ancestry, my people from 6,000, 7,000 years ago, whatever that number is, effectively, looked at the stars as they first documented what the calendar should be like. They noticed changes in the moon. They recorded eclipses. They invented things like maths and algebra and trigonometry. And learning about the history of astronomy or the history of space and how we got to where we are today teaches you so much about where we are and why we're here as well, and all the inventions that came along in the process as well.
All right, you heard it here first. Go and look up pulsars and the history of humanity's engagement with space. Rami, it has been so lovely talking to you. Thank you so much for making time. I haven't made much headway on my Chardonnay, but I hope you've made some on yours.
I think I beat you.
You've done quite well, yes. Well, I had a very large glass, so this might take me through to the evening. But yeah, it's been really nice talking to you. Thanks so much. And for our viewers, if you're interested in Rami's work, you can find Rami on Twitter. And also you can look up the Space Australia website, and we'll put the link in the description. Thank you.
Thank you so much for having me. Thanks, Annie. Thank you.